All right, so far the tests we've looked at to see if something is converging or diverging all had to do with ones that had positive terms. What if we have a series who are not always positive? And in particular today, we're going to look at series that have alternating terms. So they alternate sign between positive and negative. Here's some examples. Here you can see first term's positive, then we have negative, positive, so it's alternating here. This one, since the first term's positive, if we'd write that out, would have -1 to the n minus 1, so that when we put 1 in there, it makes the -1 to the 0, which makes that first one positive. And you can see the bottom terms there just going up 1 each time, so it'd be over n. Another series here, this one has a negative first term. And so here, if we're starting with n equals 1, then we would just put -1 to the n so that that first term comes out negative. Top numbers are just going up by 1. Same with the bottom numbers, but they're going up. They're always 1 bigger than the top, so that's how you'd write that one. So all these terms or ones we're going to look at can either be written as a series that is alternating with either the first term positive or first term negative, depending on what that is. So we're going to see a bunch that look like that today. So to see if these are going to be convergent or not, we're going to look at the alternating series test today. And this is one you should know for the AP test. When we're doing this, you want to make sure two things. When you take those terms and you take out the positive negative part, is the next term smaller than the term before it? If it is, we can apply the alternating series test. And then the other big thing, the limit as you go to infinity of the part that's not alternating should go to 0. And if it is, then this series is going to be convergent. Now you got to be careful as you're doing this, because there is some alternating series that don't necessarily apply to what we just said. So here would be an example of a alternating series right here. Each term is getting smaller than the one before it. As you can see here, each term here is smaller than the one before it. Same thing here, each one's smaller than the one before it. So if we go back to what we were looking at, this part's true, but is the limit going to 0? Well, you can see here, these dots are not approaching 0. 0 would be down here. They're approaching some other positive value. So this one you could not use the alternating series test to do. Another example, this one, the limit of this series would go to 0. But it's not going to work because if you look, the term after it's not always smaller than the one before it. Like here, if we compare half and a fourth is less than a half like we want. But if you look at the next one now, the next term should be smaller than a fourth, and that's not true here. A third's actually bigger than a fourth, so this would not apply on here. So on this one, even though the limit it would go to 0, our terms are not smaller than the one before it, so we can't do that. So you just got to make sure you check those things. Otherwise, you could get one incorrectly stated that might be convergent or divergent when it's not. All right, so first one we're going to look at here as an example, the alternating harmonic series. Remember, harmonic series is that one where it's the series 1 over n. And we have those here. We got 1 over 1 or 1, 1 over 2, 1 over 3, 1 over 4, and so on. The difference with this one than the one we saw before is it's alternating. We got a positive, negative, positive, negative, positive, negative. So we would write this one as this. This would be the alternating harmonic series. So is this convergent or divergent? Well, if you recall, the regular harmonic series we said is divergent. Let's see if this one's going to be or not. So first off, is each term smaller than the one before it? Yeah, a half is smaller than 1. A third is smaller than a half. A fourth is smaller than a third. So that checks off. So our first condition checks off. Is the limit of the non-alternating part going to go to 0 here? Yeah. If we just disregard the alternating part, this is just 1 over n. Is the limit as you go to infinity of 1 over n 0? Of course it is, yeah. So this satisfies both conditions, which means the alternating harmonic series is convergent by the alternating series test. So even though harmonic series is divergent, the alternating harmonic series is actually convergent. If you look at all those terms, they are decreasing fast enough to 0 that it is converging.